Okay, so here it is. Here's the picture, and the center is at the origin. The center is 0, 0. Okay, there
Mhm.
are 4 vertices: top, bottom, left, and right. So you have to get these 4 points down. Now, the top 2 are not really nice, and that's maybe where the issue is. So first, I guess, get the left one and the right one down. -3, 0, and 3, 0. To get the others, we have to use the equation of the ellipse. So it's a bit more involved. This one is a horizontal axis because it's wider on the horizontal. So you'd want to somehow indicate that to your instructor here. So the way to do these other 2 vertices, which they're not technically vertices, which is why the instructor's actually right here. They're just what's called the minor axis endpoints. So how to even proceed? So the you probably noticed that 3 and 3 come from 9. The square root of 9 is 3. And so these other 2 points actually come from the other number, the 5, the square root of 5. So these ones up here at the top and the bottom are 0, square root of 5 and 0, minus square root of 5. They're not technically vertices, but they are what the instructor is asking for here.
All right.
All right, so that takes care of number 3. So 8 and 9. 8 and 9 here. We'll go to number 8. All right. So unfortunately, what the instructor didn't actually specify is how to do this, and graphing it is not sufficient, although it should be. The way to do this, to determine whether it opens up or down or left or right, is to use the equations from the reference sheet that I sent you a while back. So in this problem, the decision about whether it opens left or right depends on the whether it's a horizontal or a transverse axis, which again comes from graphing. So what does the instructor want here? It's always the game. What do they want here? So let's go figure that out, because I actually don't know what they want, because you should be able to just graph it. Let's see here. All right. So the instructor, oh, this is so good. When it's in this form right here, the instructor called it x squared is subtracting. It opens left and opens right, and that's what you have in this problem. You have x squared over 9 subtracting. That is the justification the instructor uses to answer that. So I think you can just say x squared is subtracting and just say that it opens left and opens right.
All right.
And then for number 9, it's going to be the other way, the other possibility, which is y squared is subtracting. And what I just snipped in is from the notes. So perhaps the instructor just wants to see that you have read the notes, looked at the notes. I'll snip that in as well. So when the y squared is subtracting, it opens up and down. So I guess you want to say, you want to make sure you make a note that says side to side. And this one is up and down.
Okay.
All right, so the next problem, number 10. Number 10 here, the instructor has your explanation needs to be based on standard form for a conic. If the equation is not in standard form, you convert just that, then use the explanation from the lesson. Okay, let's take another look at what was actually given. Oh boy, okay. So 10 has 3 parts, unfortunately. So standard form means to put everything on one side of the equation. So it would be x squared. And actually your instructor, let's make sure I follow okay. So the standard form is ax squared plus by squared plus cx plus dy plus e equals 0. So this looks, it's got a lot of letters, x's and y's. Basically x squared and then y squared go together. Then you grab the x term. Then you grab the y term, and then you have to put the constant on the other side of the equation. Like that. So now this is in standard form, which is what the instructor wants. Okay, so that's thing one. That's thing one. Thing one is to make it in, excuse me, in standard form. All right, now decide what it is. And I think you graphed this and we found that it was a circle. Do you mind graphing this one more time just to confirm that it is a circle?
Yeah. Yeah, it's a circle.
It is, right? So the way to sort of know this from just the equation is to label, it's to label the coefficients. A is 1, B is 1, C is 2, D is 6, and E is minus 15. So this is what your instructor was looking for here. They wanted you to label these numbers and then say that since A equals B and A and B do not equal 0, then this is a circle.
All right.
Okay, so we've got 2 more of these to do, but it's the same process. So the next one here, we're going to write everything on one side of the equation. Everything on one side of the equation here. So it's 9y squared minus 4x minus 18y minus 3 equals 0. So you're just moving everything to the left.
Mm-hmm.
Is that okay?
Yeah.
All right. So now what's maybe a little bit awkward, I'll just write it here, is it's really a 0x squared in front, because you really want to be in this form where it's ax squared by squared cx dy plus, it's got to be in that order, ax squared by squared cx dy minus e. So we can write a equals 0, b equals 9, c equals minus 4, d equals minus 18, and e equals minus 3. Okay. Could you graph this for us now and tell me what you see?
Yeah, sure. Okay, so when I graphed it, it's not a hyperbola. What was its name?
So if it opens, I'll I'll snip those in here again.
It looks like a it's a
Yes,
parabola.
very good, very good. Now the way we know that just from the equation is if A equals 0 or B equals 0, but not both. Okay, so in this case, it is a parabola.
All right. All right.
Now the last one, same thing. Um, all right, same thing here. So we're going to move everything in one direction or the other. So in this case, I guess I'm just going to move the y squared over to the right. It doesn't matter. X squared minus y squared minus 5x plus 0y plus 6 equals 0. Again, you kind of want to fill in those like missing values so that you can write the coefficients. So a equals 1, b equals -1, c equals -5, d equals 0, and e equals 6. So why don't you graph this one as well? Tell me what you see.
All right. It's a hyperbola. Right. All right. Anything else that the teacher wants from us for number 10? Oh, by the way, if you're talking, I can't hear you.
Right. So that takes care of number 10. And that should be everything for the corrections.
All right. Thank you.
You're welcome. Okay, so we left off yesterday on a problem. We finished a problem and that other thing. So we'll And I just left it open and it ended up, I don't want to
Logging
say
through.
this. Well, yeah, it said, I guess I don't want to watch this video again.
Don't
Okay,
worry,
so
you don't have to worry about it. They will not let,
th-
they're not gonna
thank,
let you rewatch it.
thank you, thank goodness. Okay, so what I've noticed here, and the questions are getting more and more difficult, and I would like in a problem like this, I would almost encourage you to say like just to um like you guess, because we didn't cover this. This isn't part of this class. I mean, I can show you how to work it out. I just don't know that it will be very helpful. But you tell me what you'd like to do. Do you want us to go through this problem? Uh, this is part of trigonometry, which is not in your course.
All right.
So do you want us to work through this, or do you want to just take a guess?
I'll take a guess, I guess.
All right.
Uh,
Try to look at the numbers in the problem and consider those when you're answering.
okay. Since I'm just making a random guess on this one, I think it's um the last one.
Okay, so make sure you consider these numbers
Yeah.
before you guess. And that answer, um, that answer does not include those numbers. Well, I guess it does. But like, okay, so here's a test taking strategy just to consider. And that, because you can tell I'm trying to see how 3 of the 4 have the same
Oh, yeah.
number there. That's one of the answers is that one,
Okay.
one of those 3. Like that's kind of where if you're gonna guess, you look for things like that to help decide.
All right. Okay, now that I'm looking at them, I feel like because the one I chose is incorrect, I feel like it might be the second one, the
The one on the right here or the
on the
bottom?
right.
Okay, let's just go with it. It really doesn't matter.
Yeah.
Um, because again, this is not something you saw in this course. Okay. This is something you should know from this course. So here we go. This is something we can do. All right. It says, what is the quotient of 1 plus I over 3 plus 4I? Okay. And there's this thing called a conjugate that we're going to use in this problem. So I'm going to show you that here. The conjugate of the bottom is 3 minus 4I. Notice it's exactly the same as what's written in parentheses, except for the operator. Plus switches to minus. It can also be minus to plus.
Mm-hmm.
Okay,
So
so we're going to do it for the top and the bottom, and it's really it's an exercise in foiling. Okay, so we need to foil the top and the bottom. All right, so I'm going to foil the top, and then you're going to foil the bottom. So the bottom is, or the top is 3 minus 4I plus 3I minus 4I squared. So foil, multiply the first, multiply the outsides, multiply the insides, multiply the last. So could you foil the bottom for us, please?
yeah. Okay, when I foiled it, it's gonna be it's out of order, but I'm gonna put it in order. Negative 4i squared plus 12i minus 12i plus 9.
Okay, so the last one, it's 4i times minus 4i, that's minus 16i squared.
Oh yeah, oops.
And
Okay.
I miswrote one of these, this is 12. Okay, really good. I mean, that's well, if we had more of these, we would practice, but they only give you one, so. All right, now, couple of things here. We're gonna look at just the numerator and then just the denominator. Let's reframe it here. So in the numerator, it's really 3 minus 1i, because minus 4i and positive 3i make minus 1i, they cancel. The I stays, but you can add them up. I squared equals -1. That's an important thing in this part of the course. This last part becomes minus 4 times -1. Take a look at that and just make sure you comfortable with how that's been simplified, please.
All right. So for the denominator, it's gonna be negative 16i squared plus 9. Like that's the
Right. So it's 9 minus 16 times -1 though, again. So you kind of want to follow the same
okay,
pattern
got it.
here.
Okay.
Now, what you're noticing and what I think is important here is that you get just a number on the bottom. So the bottom becomes 9 plus 16.
Okay.
The top though is this minus 4 times -1 becomes +4. So it's 3 minus I plus 4, which becomes 7 minus I over 25.
All right.
Now, you're supposed to divide both of these by 25. Okay. And if you need to, you can think of there being like a 1 in front.
Mm-hmm.
So now we have our answers. We'll take a look at those. Which of these matches up with the one that you selected?
The third one.
You got it. Good. Okay. Nicely done. Boy, so they actually give you one that's more difficult.
Oh my God.
Right. So we're going to do this in pieces. We're going to do the first one, then we're going to do the second one, and we'll combine the results. So for the first one, 3 minus 4i, 3 plus 4i, we are again going to multiply by the conjugate. The conjugate is 3 minus 4i, 3 minus 4i. All right, so I'll do the top. The top is 9. In the order, it doesn't really matter, but if you're going to take more math, you really want to follow the patterns that you're seeing in the course here.
Mm-hmm.
So go ahead and if you could foil the bottom for us, please. Should look very familiar to you.
So we do the same. It's just it's like no, it's not the same thing on the bottom. There's an addition sign this time. Okay.
Well, the bottom is more like the one you just did in the previous problem.
Yeah. I better not mess up my my signs. It's it's 9 minus 12i plus 12i minus 16i squared.
Very good. Yeah. So again, you notice that you get some cancellations down the bottom. And remember that I squared equals -1. Can you tell me what the bottom becomes?
9 plus 16i squared.
That's right, but I squared is really -1.
Oh, so minus.
Okay, so could you fully simplify that for me? Just the bottom.
So it would be like 9 minus 16 squared, but
So if you look back in the previous problem here, I replaced I squared with -1.
oh, right.
And that's what I'm asking you to do. I'm not asking you to do anything different. Just asking you to replace it and simplify. So down here, I'm asking for what is 9 plus 16i squared. What does that become?
Okay, it's going to be 9 minus 16.
Okay, that's correct.
All right. So wouldn't it be for the fraction, like for the top and the bottom? Wouldn't it just be the same thing? Like,
I'm just asking for the number on the bottom, nothing more.
yeah. So
Nothing
9
less.
minus 16, which would be 7.
It's not 7.
Oh, dang. Okay.
You're welcome to use a calculator if it will help.
Oh, wait, it would be -7.
Yeah. All right, now the top is -7 minus 24i. Okay. And that's just this first part. Okay, so unfortunately we got to do the other part, but it's very similar. So it'll go pretty well here. We're gonna do this part next down here. So it's 3 plus 4i over 3 minus 4i. And we're going to again multiply by the conjugate.
All right.
All right, so I'm going to do the top. I'm going to multiply the top here. You're going to do the bottom. Top is 9 plus 12i plus 12i plus 16i squared. Could you multiply the bottom for me, please?
Yes. 9 plus 12i minus 12i minus 16i squared.
Okay. All right, so could you tell me what the bottom becomes this time? Just the bottom.
So the bottom then becomes 9 plus 16, because
Okay,
you said we multiply by -1.
that's right.
So 9 plus 16 would be 25.
Good. Top is -7 plus 24i. And now we just did piece 1. Now we're doing piece 2. We're going to combine these two results. Okay, so do that next.
All right.
All right, so we're going to add these together. Now on the left here and the right, we're going to divide both So it's minus 7 over minus 7 minus 24i over minus 7 plus minus 7 over 25 plus 24i over 25. So just make sure, take a look at this. All I did was divide each of these by the bottom.
Mm.
Is that okay?
Yeah,
Although this isn't working, it's working out. Why isn't it working out? Let me check on something here. All right, here's the problem. This was supposed to be a negative. That's the issue there. So this should have been 25, which makes this 25. That's now it's going to work out. All right, so let me do this. Okay. So do you see that the i's have the same coefficients, 20 minus 24 over 25 and positive 24 over 25? These are exactly the same except for the coefficients.
yeah,
And then you can actually add these two fractions together and get minus 14 over
25.
25, which, believe it or not, is one of the answers. Which is this one over here on the left.
Yay.
So probably noticing the more we do these, they get longer and more challenging, but that's okay. So here is another problem for us to look at. This one is within the scope of this course. It's actually something you might have seen in a previous course, so it's okay. It's doable. I've accidentally hit this one just when I was routing the snip, so it may not be that one, or it may be. All right, so the way to just to kind of reframe this, the square root of y can be written as y to the 1/2 power. Do you remember that from earlier in our work together?
Yeah,
Okay. And the thing that's also important here to remember is that when you have a negative exponent, you can actually flip what's inside parentheses. So the negative exponent flips what's inside here, and then you make it positive. Then there's furthermore this rule where you can apply the exponent to both things inside parentheses, but you have to know what math operation it is. So when you have an exponent to an exponent, you end up multiplying the exponents. So I'd like you to multiply 1/2 and 1/10.
all right. That's gonna be like 1/7.
You're multiplying, not
Yeah.
you got to multiply the bottoms.
I don't know why I was thinking we were adding for 5 seconds. I'm sorry. It's gonna be 1/10.
It is 1/10. That's right. Now the bottom, any 1 to any power is always 1, so the bottom just remains 1. Okay, so this is your answer. Your answer is y to the 1/10 power, but notice none of them are in that form. So you have to remember how to rewrite something with an exponent. So remember, x to the 1/2 is really the square root of x with a 1 and a 2 there.
All right.
So notice the way what we would write y to the 1/10 power. Would the 10 go, if you look at the previous problem, would the 10 go in this kind of position called the index or above the y?
Mm.
Basically just ask you to look at where the 2 is. Where's the 2? And say, okay, the 10 is going to be in the same position.
Okay, so basically it's gonna be like 10 square root y to the power of 1.
Yes, and it's actually, it would be called the 10th root. Index is 10, but that's a small thing, so it is this one here. Okay, so starting to see some repetition, which is good. All right, what is the quotient of the complex number 4 minus 3i divided by its conjugate? So 4 minus 3i divided by its conjugate is 4 plus 3i. Okay, and what we've been doing is we're now multiplying both the top and the bottom by the conjugate. So we've done this a number of times, but we'll do it yet again here. I'll do the top. So it's 16 minus 12i minus 12i plus 9i squared over 16 minus 12i plus 12i minus 9i squared. All right, so now I'm going to grab the top. We're going to work on the top here. So I want you to look at the top now, Ivana, and notice that the 12 i's don't cancel, but the 9i squared, 9, you're really going to multiply by -1 here. Could you tell me what the top becomes?
So from the top, it's the same thing as the last problem we did, except this time the 9 is the squared one. So
Sure. Yep.
it's gonna be 16 minus 9, which is 7. I'm doing
Okay.
it.
Minus 24i.
Yeah.
Because both. Now do the same thing for the bottom.
Okay. And now it's gonna be 16 plus 9. So it's gonna be 25 minus 24i for the
We're
bottom.
looking at just the bottom,
Yeah.
bottom again.
Okay, so it's gonna be 16 plus 9, which is 25. And then it's gonna be minus 24i, so it's gonna be 20.
Are you looking at the bottom?
Yes.
Okay. Well, the bottom
I'm
has minus
sorry.
12i plus 12i.
I'm blind. It's just 25.
It's 25.
I
Okay.
think I'm just a little tired or something. I don't know.
Good. Okay. Now I'm going to put the answers in front of you, and you're going to have to look back at your notes, but one of them is reflected here in this answer.
It's gonna be the second one.
All right. Very good. Okay. So this is it's a new problem here. I think this is outside the scope of your course. Well, I take that back. I guess we can kind of set this up. A, B, C, and D are non-zero integers. If A over B is added to X, they're saying A over B is added to X, so X plus A over B, and the sum is C over D. Okay. Now let's solve this for X. Okay. How would we solve for X here? How do we undo this thing right here?
How do we undo that?
Yes,
You would multiply.
but this is addition.
Yeah,
How
but
do you undo addition?
oh, okay, so we would subtract.
Okay, so on the left, it's just x, but on the right, it's d over d minus a over b.
Mm-hmm.
Okay. Now, one of the things you should notice about the answers here, sometimes it's good to go back and look at the answers, is this is one fraction, one fraction, one fraction, one fraction. Okay. This is two fractions. Do you remember how to make two fractions into one fraction? Like if I asked you to take 1/2 and subtract 1/3, how would you do that?
We would have to make it the same denominator.
Yes. Okay, so it's the same idea even with the letters. So the denominator is, you ask yourself, well, what does one have that the other does not? So the one on the left here does not have a b. So you multiply the top and the bottom by
A B.
b. And then on the right, it's the same thing. You ask yourself, well, what is b missing? Well, it's missing a d. Multiply the top and bottom by a d. So now this becomes CB over BD minus AD over BD. And now they have the same bottoms. So since they have the same bottoms, you can rewrite the tops together.
Mm.
All right, so which of these,
The last one.
yeah. that's-
The last one's the only one that everything is the way that we wrote it.
All right. All right, so here's what I want you to do for the next one. I want you to graph this polynomial. Go ahead and graph it. And then I'll ask you some questions about it.
Mm-hmm. All right. Oh my God, I have to solve this.
So you just put this into the Desmos.
Scientific or cat? Yes.
Or to graph it, you've got to put it into the graphing calculator.
Or let me just do that, I guess. Okay, I graphed it. It looks like a transformation in a way.
Okay, so does it cross the x-axis? The x-axis is the horizontal one. Does it cross the x-axis?
Does it cross the x-axis? No, wait. Yeah, no. It crosses the y.
It does cross the y. I agree with that.
Mm.
Okay, now what I want you to do is just add a little thing to the end. I want you to subtract 6.8 at the end.
Okay, so let me
And
put,
then tell me how many times it crosses the x-axis.
all right. It crosses the x-axis by a little.
I'm asking how many times does it cross the x-axis? I'm asking you to count how many times. Yeah, if it across means it goes across. That would be one time.
Okay, it crosses it 2 times.
Okay. is this, I'm gonna snip something in here. Is this what you have graphed?
Yes.
Okay, I want you to count again. It crosses more than twice.
Oh, okay.
And you know, zoom in as much as you need, but
Oh, it crosses 4 times.
it crosses 4 times exactly. All right, very good. So that is the answer, 4 times. We're going to go ahead and stop here for the moment, but we'll pick back up here in about 10 minutes. There's a new link for you to click on, and I'll see you shortly.
All right, see you shortly.
Thank you. Bye.